Hello everyone. This lecture is the first lecture of a series of lectures intended to teach computer programming using C. We will adhere to the syllabus of Institute of Engineering, Trivandrum University, Nepal, and discuss on C programming. This lecture series does not assume any prior knowledge of programming languages or programming experience. However, such experience would be an added asset. We will talk about general introduction of programming languages in the first lecture. We will discuss the type of softwares under system software and application software. Then we'll talk about general software features and recent trends. After that, we'll be talking about generation of programming languages and classification of high-level languages. This will be all to our first chapter. In the first lecture, we'll be only discussing some few topics. To begin with, let us talk about software and program. Nowadays, the term software and programs are used interchangeably. However, there is a subtle difference between them, and I think we should know about them. Software is a broad term that is used to identify programs, data, and other related files that are used to accomplish certain tasks in a computer. Not all parts of a software are called programs because not all of them contain instructions. Some of them merely contains data or images that are used to provide interface to the user. In this way, we can say even a program is a software. In a broader sense, programs are any sort of instruction that are executed by a machine, and they existed prior to the coining of the word software. An excellent example would be the punch card that was used by Jacques Loom in the beginning of 19th century to automate his sewing machines. It automated the process, and weavers could pick the design by choosing a particular punch card, and hence it materialized the concept of program. However, the same punch card cannot be called a software. With these differences in mind, we can call computer programs to be a software. I repeat, computer program, not all programs. And when we refer to a program in our lecture, we'll be only referring to computer programs. Hence, for us, in our lecture, all computer programs or software refer to the same thing, and we will be using them interchangeably. So what is a computer software? Software is a set of commands that tells a computer to do a particular job. It has a list of instructions that are obeyed by a computer system. Without software, computers or other hardware would be useless. They are called software because they are relatively easy to change, as the word soft implies, meaning we can easily change what software we are going to play right now, unlike in hardware. Hardware, on the other hand, are, as the names hard suggest, they are hard or physical in nature, and they are not so easy to change. You can update an Android version in your mobile, but you cannot change mobile as often as you'd like to. From a simple calculator to a complex analytical tools or softwares, and from Minesweeper game, from a very simple Minesweeper game to complex FIFA games, all of these belong to the domain of software. If you remember correctly, I have talked about programming languages. So what is a programming language? What kind of software it is? To answer that, programming language is a special type of language or a tool that provides programmers or its user to design softwares. That is, it is used to design software, scripts, and write other set of instructions for the computers to execute. In simple words, programming language is software that allows us to make a new software, unlike other software. Now let us return to our discussion on softwares. Software can be broadly divided into two types. They are system software and application software. Let us begin by talking about system software. What comes to your mind when you talk about the word system? Whenever I hear the word system, I remember its operations and the system as a whole. How the system operates as a whole. So, system software is a software that is used to operate and control the basic system working. So, system software is a software that is used to control and operate our system. Without it, working on the system would be a really hard task. Because the system can only operate with the use of these kind of software that are also known as system softwares. Imagine running our system without OS. Would we be able to do it? Would common people would be able to do it? It would be very hard for us to operate on those things. Also, system software provides abstraction or platform to application softwares that we use in everyday life. Without the underlying platform of OS, it would really be hard for us to use the application software. So essentially, system software is responsible for integrating, controlling and operating our system and giving the real sense of system to our hardware and software. If we think of a computer system as a layered model, then we can notice that system software lies in between hardware and application software. Therefore, it also provides abstraction to application software, meaning the users using the application software can use the underlying hardware without the knowledge of the hardware and basically deal with only the system software. That is what we are doing in everyday life. Do we know what goes on in MS Access when we type when we type a letter A in our keyboard, and how does the letter A show up in the screen? No, we have no idea. But we are able to print and do a whole lot of operation on the computer without knowledge of any undergoing operations or processes. That is what system software or OS does. Now, OS is not a synonym of system software, but rather it is just an example, and it is the best example of OS. There are other examples of system software. Some common examples of system software are BIOS, bootloader, device driver and assembler. Let's talk briefly about them. The BIOS gets the computer started after you turn it on and provides for the data flow that takes place between OS and other attached devices such as hard disk, mouse, printer, etc. Similarly, the boot program loads the operating system in the computer's main memory or RAM. Next, assembler. An assembler is a program that takes instruction and converts them into machine level language in patterns of zeros and ones. Next, we'll talk about device driver. Device driver is an important concept. A device driver controls a particular type of device that is attached to a computer, such as mouse or printer. The device driver converts the more general input-output instructions of an operating system to the type of messages that the device can understand. These were some of the examples of system software. Now we'll talk about application software. So, what is application software? Application software is a type of software that is used to accomplish a certain type of task rather than controlling or operating a system. Application software may consist of a single program that only accomplishes a single task, such as image viewer or a media player. And it may also consist of a package software that consists of a number of packages for doing separate tasks, such as Microsoft Office packages, Lotus Suite, etc. So as the word application suggests, these are used for everyday application of user and can vary according to the application of the user. One important distinction between system software and application software is that system software has to play directly or interact directly with hardware, but application software do not have to interact directly with the hardware. Let us further our knowledge about application software by discussing on the types of application softwares. We can discuss the type of application software in three subheadings, namely tailored software, package software and utility software. Let's first talk about tailored software. What comes to your mind when we hear the word tailor? Someone who fits your clothes or apparel according to your need and desire. So, tailored software is a particular type of software that is used or that is designed to address your concern. These type of softwares are designed to address a set of problems that you are facing as an individual or as an organization. It particularly relates to your understanding of your problem and will only do those things that you want it to do when you design it. So when you want to get a tailored software, then you go to the software designers and then ask for a particular type of software. These type of softwares are called tailored software because they are tailored to your needs. An excellent example of this type of software would be the DBMS software employed at Thapathali Campus that keeps a record of all the students currently enrolled in the campus as well as all the alumni of the campus. Another example to fit this category would be the software that is employed to keep a track of all the financial transaction and economic activities of the campus. So one question for you, Can the DVMS software used at Thapathali Campus can be employed at Pulchar Campus directly? The direct answer would be no. Because the software would only address the needs of Thapathali Campus, it cannot be directly employed to Pulchar Campus. Yes, it can be employed with little variation and some changes and adjustment so that it can be adopted for Pulchar Campus. So basically you get the point. Tailored software are tailored for your needs and or designed to fit or address a particular goal or your goals that you want to be answered or addressed. The next type of softwares are called package softwares. So what are package software? Many software houses study the common requirement of its customer or its end users or target users and develop certain packages so that it addresses a common goals of those people and with the intention that the upcoming software can be bought by those people. So there is much less interaction between the end user and the delivering company on one hand, but on the other hand there is less chance of having error because these type of softwares are generally produced by big company houses with professional teams working for such softwares. Some examples would be MS Office package, Lotus Suite package and other packages. To have an in-depth knowledge of these things, let us take an example of Word, MS Word. MS Word has a list of functionalities. Let us say you are a student and you only require a word processing and printing or simple editing. But MS Word has a list of functions that far exceeds your own needs, but you are still using it. Remember, it had been designed keeping in mind about the general interest of a very large domain of people, and it does not directly address only your needs, and it has to address all those people. It has to be bought by all those people. Therefore, these softwares are usually made for a common group of people with some common interests. I hope the idea is clear. Now, one of my students had asked in my class about VLC being what kind of software. What do you think? VLC is also a type of package software that is designed by someone somewhere else that can play certain number of files, certain kind of movie files, and does a few things, does other things as well. But it does not answer only a particular need that you feel and addresses the concerns of many people. Therefore, it is a package software. Web browsers, computer games also fall in the same category. The third kind of application software is utility software. These type of softwares help us fine-tune the performance of our computer, that is, make them more utilizable, or they tend or refer to the utilities that are meant to keep our workstation properly functioning. They allow us to analyze and maintain our computer. For example, antivirus softwares scan for viruses and keep our systems away from them and safe from them. With the help of backup utilities, you can back up important files and keep them safe. Similarly, data cleanups, disk defragmenters, disk cleanups are some other examples of utility softwares, and these softwares are basically employed to maintain our computer system. Now we'll move on to the next topic, that is called features of good programming language. Well, there are many features of good programming language, and we'll be only discussing some common and important ones. We'll discuss the topic under simplicity, naturalness, structure, compactness, and clarity. Let us begin with simplicity. Mind it, we are studying about the good features of a good programming language and not softwares. Those are a little bit different topics, although it might also be fit for softwares. So let us talk about simplicity. A good programming language should be simple and easy to learn. It should provide the programmer with simple, easy to learn and unified set of concepts that can help him deal with his objective. The overall simplicity of the language strongly affects the readability and the type of softwares that an user can produce. Further, those programs that are easier to read are thus easier to maintain and update regularly. A good programming language should be natural for the application area for which it has been designed. Meaning, it should provide the users with the appropriate symbols, data structures, and the required functionality so that he does not feel alienated to the platform. It should be very easy to use, and it should feel more natural for the programmer to use. Efficiency. Programs written in good programming language should be able to be converted to machine level language with high efficiency, so that it occupies minimum area as possible and is very fast to operate. That is, a good programming language should give benefit to its user by saving his space in computer and his time. Structured. A good programming language should allow a user to make his logics more structured or modular. This property moreover forces a programmer to write his program in a much logical fashion than in a random or less organized pattern. And it also aids to actualize the concept of modularity. Compactness. A good programming language should allow its user to command or write a set of commands to a computer very precisely and concisely. Let's say we have two codes that are doing the same task. The first one takes 100 lines to do it, while the second one takes only 50 lines to do it. Which would you prefer? Of course, the one with less instructions. So, the programming language should allow its programmer to write instruction as precisely and as concisely as possible. The final feature is clarity. Programs written in good programming language should be readable. It further aids maintenance. Next, we'll discuss about the recent trends in software industries. So what do you see around you when you look into the softwares that you use currently? Some of the most recent trends that have been seen in the software industry can be discussed under the following headings: easy step-by-step installer, regular updates, database, support, user-defined personalization, and powerful search engines. Let us start by discussing on easy step-by-step installer. Software companies these days make it their priority to accompany their softwares with an easy step-by-step installer. It aids the user in easy use without any hassles. Next, support. Companies nowadays allocate a huge budget or expense to provide support to their customers, as this is a very determinant factor to flourish their company. Next, updates. Companies nowadays release newer and newer updates of their products to keep the product up to date, and also add newer and interesting features so as to keep their customers attracted. This helps the company compete with other companies as well and make the software more usable and time friendly. Next, database. Have you noticed these days many software available in the market allow users to log in and make the software more individualistic? That is, it keeps the data of the individual in the product itself. Therefore, this kind of software require a huge space or database to keep the list of all these information in with them. When two softwares with similar features come into the market, what determines which one will flourish? The answer to this question is how close the software can be with its users. So the next topic is user-defined personalization. It basically allows users to make or modify the software's use or context according to his desire. For example, Viber allows its user to change the background of the chat box whenever he or she wants it. This allows the user to have a bit of control in the software and thus feel more naturally inclined to use it. Powerful search engines. Software-related database should employ powerful search engines to allow users to get to a particular information in a short time. To comment on all this at the same time, I would like to take an example of Clash of Clans, which has been a huge success in recent days among youths. This software or an application can address all the above topics that we've discussed. First, we can easily download it from the App Store without much hassle. Anyone can do it, even a child of 5 years old, maybe less. It had recently released an update of the product to keep the users who had reached the final levels still engaged in the product. Also, it added newer features in the product so as to make the game interesting. Since everyone can log in from the devices to play the Clash of Clans, it has a huge database built in. The database logs in information about everything. It's town hall level, the number of amount of elixir and coins and everything. So just imagine the amount of information that needs to be saved for this particular app. The team is up for support activities as well. When a client needs to go to a war, the software searches for its opponent very smoothly. It must have a powerful search engine to allow so many searches to take place at the same time. I hope these concepts have become clear. So in this lecture we discussed some basic difference between programs and softwares, and then under them we discussed the type of softwares: system and application software. Some examples of system software we discussed was OS, BIOS, device drivers, under application software we discuss three types: tailored. We took the example of DVMS system used in Thapathali Campus as an example of tailored software. Then we discussed package software. Some examples of package software were MS Office Suite, Lotus Suite, VLC as well. Then utility software. Some examples of utility software were antivirus software, disk cleanups, etc. We then discussed features of good programming language under simplicity, naturalness, efficiency, structured, compactness, clarity. Then we talked about recent trends, in which we talked about easy, step by, installer, updates, support, user-defined personalization, and powerful search engines. This is all for the first lecture. Thank you all.